Hi guys, we shall talk about the refractive error of the eye. So we have myopia, hypermetropia, astigmatism and presbyopia. So we'll make few videos about this refractive errors of eye. This is very important. So basic understanding of refractive errors of eye. So if you're having any refractive errors of eye, that means you are known as ametropia. This can be divided into myopia, hypermetropia, astigmatism. Okay, or you might not have any issue, that is you are called as emetropia. You're happy, you're lucky. Okay, then you're called as emetropia. You're having some issue with the eye, refractive issue, then you're called as ametropia. Now this ametropia can be myopia, hypermetropia or astigmatism. So now what is myopia? Before that, let's just study in normal fashion. So this is your lens, you have your cornea. So this is the rays of light coming from the infinity. It will focus like this onto the retina. Okay, that's a normal thing. Now there's another principle we should know. This is a lens again, that's a cornea. This is the rays of light coming from infinity from a far distance. Now if this rays of light is coming from very near, it will not directly enter. It will first diverge, then become parallel, and then become converge. Okay, these are two things that we should know before we start. So what is happening in myopia? The image is actually forming in front of the retina. The myopia you can define as that it's a refractive error of the eye in which the image is formed in front of the retina when the accommodation of the eye is at rest. So number one cause of myopia is 90% cause of myopia is something known as axial myopia. The normal axial length is 24 mm. Normal is 24 mm. In axial myopia, this length is increased. That is the reason we say in myopia the person is having bigger eyes. Okay, so now what happens is that the rays of light is coming from parallel. Okay, you have the cornea here. It will be focused in front of the retina because the power of cornea, the power of lens is constant, but the retina has shifted behind. That is the reason image is formed here. Okay, so the person will complain, I'm not able to see further distances. Okay, long distances I'm not able to see. Now will the person have difficulty in reading something which is near to his eyes, that is reading a newspaper or reading a book? The answer is no. Why? This principle. Let's understand by the diagram. This is cornea again. So if an image is something here, point, it will first diverge. So it will take some time to become parallel, and then it will become converge. Convergence will take place. So eventually it will take some time. So it will eventually fall onto the retina. Okay, normal eye, the retina would have been here, but because of axial myopia, the retina moved here. But the point which is near, something is reading very close to the eye, it will first diverge. It is always true in any condition. It will diverge, then will become parallel, then it will become convergent. So it will take some time to become parallel, take some time to become convergent. It will take some time to focus. Okay, it will take some extra length. So that's the reason it is helping in this condition. So the person will have difficulty in looking long distance. It will be blurred, but good in this normal condition. So another thing we should remember here is the axial length is 24 mm. Okay, and with increase in 1 mm, we have 3 diopter change. Okay, if this axial length increases, let's say it's 25, they will give 3 diopter. If it is 26, will give 6 diopter. Okay, so with this, let's say a person is having a glass which is 21 diopter. So what is the axial length? So 21 divided by 3 will give us 7 mm. Now 7 mm, you might think it is the axial length. No, this 7 mm is the extra length. Normal length is 24, so we'll add 24 plus 7, which will give us 31 mm. 31 mm is the normal axial length. Okay, so the 24 mm is normal. Let's say the person is having 25 mm, will give 3 diopter. Will have 26 mm, will give 6 diopter. Okay, S means spherical, minus means negative power that is given for myopia, that is on concave lens. Okay, now we understood this. Now what is the treatment? Okay, what is the treatment? So again, draw the this, understand. So we'll place a concave lens here. So the rays of light coming from parallel will first diverge. Remember we told diverge, then it will become parallel, then it will converge. It will take some time. So eventually it will focus on the retina. We give concave, which is known as divergent, and the power is negative. What we give for myopia. Okay, what will the person say? He's not able to see farther distance, will be able to see nearer distance. Why will be able to see nearer distance? Because of this phenomena. Anything which is very near to the eye will first diverge and will become parallel, and then it will become converge. Okay, so anything which is diverging, it will take some time to become parallel, then some time to become convergent. Whereas the rays of light, if it's coming from infinity, it is already parallel, so it will directly become convergent. Okay, so we give concave lens here. So that's it. So normal is 24, and concave lens here, divergent lens, we give negative power. And let's say if the person is numerical, maybe if the person is wearing -21 dioptric glasses, then what is the axial length? So divided by 3, this is 7 mm. 7 mm is not the actual one, we have to add it with the normal value, it is 31 mm. Okay, 24 mm is normal axial length. If the person is having 25 mm of axial length, we will give -3, 26, -6. Okay, so increase in 1 mm of axial length will give you 3 dioptric powers. So another fun fact is that whenever you see a person is wearing concave lens, that is for myopic issues, that person will be wearing the glasses very near to the eye. That's a principle, just know the principle. Concave lens, it works better if it is held very near to the eye. The person will not allow the glasses to drop down, onto his nose. Is always pushing glasses near to the eye. And another problem with concave myopia, which is concave, there is a problem called as minification. Okay, there is minification problem here. So what is the formula here? This every 1 diopter of concave lens will give you 2% minification. It means the image size will drop. Okay, let's say there is 10 dioptric power, I am using 10 dioptric power, then the image size will reduce up to 20%. It's a good amount, 20% the image size will reduce. So this was what about myopia, and yeah, thanks.